Are you struggling with the Source.Queue pattern in Akka HTTP? You're not alone. Many developers face challenges when implementing this powerful feature. Today, we're going to break it down and help you understand how to use it effectively. I get it. Implementing new patterns can be daunting, especially when the documentation leaves you with more questions than answers. You're probably wondering why source.single is considered an anti-pattern and what the implications of using source.queue are. Here's the specific question we're addressing today. A user asked about the source.queue pattern in Akka HTTP and its advantages and issues. They provided a code snippet and expressed confusion about the thread safety of the queue and the differences between queue size and max open requests. Sound familiar? Let's dive into it. So, what do we need to know about source.queue? First, it allows for explicit backpressure handling, which is crucial for managing load. However, it's important to note that the queue is not thread safe, which can lead to unresolved futures if not handled properly. Let's clarify these points. And stick around. By the end of this video, you'll have a clear understanding of how to implement source.queue effectively and avoid common pitfalls. To begin implementing the source.queue pattern, the user should first create a cached host connection pool. This is done using the HTTP method from Akka. Next, the user needs to set up the source.queue. This queue will handle the HTTP request and promise pairs, allowing for backpressure management. Now, the user should implement the queue request function. This function will offer requests to the queue and handle the different outcomes. Finally, the user can test the implementation by calling the queue request function with a sample HTTP request. This will demonstrate how the queue processes requests. Fun fact, did you know that the concept of queues in programming dates back to the early days of computer science? They were essential for managing tasks and resources efficiently, just like in our code today. Now, let's look at the answers provided by other users. The user addresses several questions regarding the source.queue pattern. They confirm that while a flow is materialized for each incoming connection, there can still be performance benefits when multiple requests come from the same connection. They clarify that streams do not guarantee a one-to-one mapping between source and sink elements, which can lead to unresolved futures if requests are filtered. Regarding queue size versus max open requests, they suggest that the ideal ratio depends on the processing speed of requests and responses. The user proposes a redesign approach, suggesting that instead of using source.queue, you can directly create a source from a collection of requests. This eliminates the need for a queue and simplifies the design. They also mention that even with dynamic request sources, you can still use a source to maintain a reactive stream without a queue. The only time a queue might be necessary is when dealing with callbacks from third-party APIs. Here's a pro tip. Always ensure your queue implementation is thread safe and consider using explicit backpressure strategies to handle load effectively. This will save you a lot of headaches down the line. And there you have it. You now have a solid understanding of the source.queue pattern in Akka HTTP. Remember, implementing it correctly can greatly enhance your application's performance. If you found this video helpful, please subscribe for more insights and tips.